Assalamualaikum warahmatullahi ta'ala wabarakatuh. Bismillahirrahmanirrahim. Now we reach at the last subtopic of chapter 1, which is volume integral. So previously you have done line integral, which use single integration. You also have done surface integral, applying double integral. Now volume integral. Okay, what happened in the volume integral? So basically, volume integral refers to an integration over a three-dimensional domain. You have a solid, you have a cuboid, you have a cylinder, you have a sphere, you have a tetrahedron. You're going to integrate you're going to solve the volume integral over the solid, where you actually want to know the volume of the solid. So it's also known as a triple integral of a function, can be in terms of x, y, z, where it's generally written as follows. You can see we use here triple integration. Okay, triple integration, and we write V here, denote the volume, and the function should be in terms of x, y, z, and this is the general integration form, dx dy dz. It could be changed to be dy dz dx, or it also can be in terms of dz dy dx, and it also can be in terms of another integration form, which consider the polar coordinate of sphere, cylinder, which depends on the question. Alright, let's start with the first example. In the first example, you are asked to evaluate the triple integral of f, where f is 3 exponential x squared plus y squared plus z squared power of 3 over 2, and v is a region bounded by y equal to 0, z equal to 0, and the surface x squared plus y squared plus z squared equal to 16. Alright, first of all, as I've mentioned before, you should recognize the equation. So basically, what I have shared in your group telegram, this is a sphere. This is the equation of sphere. But now the equation said, the question said, the equation is combined with another equation, y equal to 0 and z equal to 0. So when the equation of sphere combined with another plane y equal to 0, z equal to 0, so what can we say that this is a half hemisphere? This is half hemisphere. Okay, you imagine you have a hemisphere, and you cut the hemisphere at half. So now you can see the bottom of the plane is z equal to 0. We have the plane at bottom, z equal to 0. We have the plane at the back, y equal to 0, and we have the plane above here, which is x squared plus y squared plus z squared equal to 16. We have three plane altogether. Now you are not going to integrate surface, you're going to know the volume integral. So you're going to integrate the whole sphere. Okay, alright. So as you know, when you do the sphere, integration of sphere, you have to remember that you have to apply polar coordinate of sphere. Okay, let's refer in your book. X equal to r sine theta cos phi, y equal to r sine theta sine phi, z equal to r cos theta, and now you want to do dv, volume integral. So check in the book, the dv is r squared sine theta dr d theta dv. Alright, so this is based on the polar coordinate of sphere given in the book. Alright, now, so first of all, you have to make sure the function that you are going to integrate, okay, as we know that you are going to integrate, you want to do the triple integral of 3 exponential x squared plus y squared plus z squared power of 3 over 2, and your dv is r squared sine theta d theta dv. This is best exactly from the formula, so from the polar coordinate. This is dv. Okay, this is dv. Alright. So in order to use this dv, this integration form, you have to make sure the function that you are going to integrate also is in terms of the r d theta dv. Sorry, this should be in theta d theta. Okay, d theta. This one is d theta. Sorry, I always make mistake. Sorry, yeah. Okay, right now. So make sure the function, now you have a function in terms of x, y, z. So first of all, why don't we change it to be in polar coordinate of sphere? So I write here x squared plus y squared plus z squared power of 3 over 2. We're going to solve it, we're going to convert it into the polar coordinate. So I have here r squared sine squared theta cos squared phi is the x squared plus r squared sine squared theta sine squared phi is the y squared, and the z is r squared cos squared theta, and this is power of 3 over 2. Okay, we just convert all everything x, y, and z in polar coordinate. So now you can see that we have same term here. Okay, so you can factorize it. Okay, so I have here, can you see it? Okay, 3 over 3 over 2, I will write it after. Okay, okay, this is everything is in power of 3 over 2. Alright, so now you know this is equal to 1, right? Okay, so I have here r squared sine squared theta plus r squared cos squared theta power 3 over 2. Can you see it? Because this cos squared phi plus sine squared phi is equal to 1, so 1 multiply with this, you get r squared sine theta. So now you still can simplify this. So I have, and this is everything power of 3 over 2. So I have this is equal to 1. So what I have here is r squared 3 over 2. Can you see it? Okay. So after a long equation, you simplify it based on the polar coordinate of sphere. So I have r squared 3 power of 2. Okay. So do you realize that you still can simplify this? The 2 and 2 can be cancelled out. So now you have the final equation after the simplification is r power of 3 only. Okay. Now clear. Next. Okay, now you have previously already converted the function of f x y z of 3 exponential x squared plus y squared plus z squared 3 over 2 already converted to be f r theta phi of 3 exponential r cubed. Okay, we consider the polar coordinate of sphere and substitute into x, y, and z. So we have 3 exponential 3 power r cubed. Okay, now so means that you are going to integrate the 3 exponential r cubed, and the dv based on the polar coordinate is r squared sine theta dr d theta dv. Alright, the dv based on the polar coordinate of sphere is r squared d theta dr d theta dv. Alright, now you are going to determine the limit of the integration. So what is the radius? Given in the question that the x squared plus y squared plus z squared equal to 16, right? So obviously radius is 0 to 4. Okay, because 4 squared is 16. Okay. The theta remember it has to be the limit from the z negative to z positive, but we don't have any surface below the y below below the y axis. Okay, so you just located above the y axis. So the limit of theta is 0 to pi over 2. 0 to pi over 2, half hemisphere. Okay, and then the v is the horizontal limit, so it is from here to here. Okay, so the limit is 0 to pi. Okay, I hope you are clear about this. All right, now, so you're going to integrate this. Okay, we start integration dr. Okay, so you can see that we have uh, exponential r cubed r squared, where the function is in terms of r. Okay, so what we can do is by using substitution method. Okay, so you let u equals to what? R cubed, because r cubed and r squared, r cubed has has higher degree. So differentiate respect to r, you get 3r squared dr. Okay, so 3r squared dr. So you can see we have 3r squared dr here. Okay, let me rewrite for you. So it's 0 to pi, 0 to pi over 2, 0 to 4, and then exponential u, 3r squared dr sine theta d theta d phi. I arrange this so that you can see this is u from here. 3r squared dr. The 3r squared dr from the previous equation, I rearrange it, okay, so that you can see this is u, so you can rewrite it to be so that your integration will be easier. Okay, 0 to 4 du du sine theta d theta d phi. Okay, now, okay, okay, so you have du, so integrate it 0 to pi, 0 to pi over 2, integrate exponential u, you will get the same thing, exponential u 0 to 4, sine theta d theta d phi. Okay, let me make it sine theta d theta d phi. Okay, clear, right? Okay, so exponential u, integrate respect to u, you will get the same thing, exponential u. So this is the limit sine theta d theta. Okay, now substitute u. You have to do one by one. Okay, class, exponential u is exponential r cubed. Okay, 0 to 4 sine theta d theta d phi. Okay, why do I move to next slide. Okay, so what happened is, okay, we have 0 to pi, 0 to pi over 2. Just now is exponential r cube 0 to 4 sine theta d theta d phi. Okay, now substitute the limit. You have 0 to pi, 0 to pi over 2. Okay, so exponential 4 power of 3 is 64 minus exponential 0 is 1 sine theta d theta d phi. Okay, how I get exponential 64 is exponential 4 power of 3, exponential 0 is 1. Okay, now clear on R. So now integrate sine theta. So this is already constant, 0 to pi. Okay, integrate sine theta is negative cos. So exponential 64 minus 1 is constant, just like it. like just let it is like that. So you get cos theta 0 to pi over 2 dphi. Okay, so now substitute the limit. Okay, exponential 64 minus 1 remain as it is. So negative cos pi over 2 minus cos 0 d phi. Okay, I substitute limit. So cos pi over 2 is 0, cos 0 is 1. So what happened is I get 0 to pi exponential 64 minus 1, and I got 1 here. Okay, so 1 no need to write lah 1. Okay, so I just have this. So now integrate exponential 64 minus 1 respect to phi. I got phi exponential 64 minus 1, limit is 0 to pi. Okay, integrate a constant. Let's say you integrate 4 respect to phi, you get 4 phi. Now exponential 64 minus 1 is a constant. Integrate respect to phi, so just put phi. So now substitute the limit. So the final answer, you will get the final answer of x pi x of exponential 64 minus 1, and if you substitute 0, it gets 0. So this is the final answer. I hope it is clear. So thank you. Okay, Bismillahirrahmanirrahim. Assalamualaikum. So this is example number 2 for volume integral. So evaluate triple integral f dv for the scalar function f equal to z minus x plus 4yz, and v is the closed region bounded by the planes x0, x10, x0, x equal to 10, and y squared plus z squared equal to 25 in the first octant. Okay, these are the keyword that you have to notice here. Right, so first of all, you have to make sure you know what kind of plane, what kind of solid is it, okay, that you're going to do the volume integral. Right, so do you recognize this equation, y squared plus z squared equal to 25? Basically, in the two dimension, you have, let's say, z and y. It is a circle, right? Am I right? It is a circle, right? With the radius is 5. So maybe here is 50 because it is 25. So the power of 2 is 5. So this is a circle in two dimension. But now, this equation also supported by x equal to 0 and x equal to 10. So means that this is a cylinder. The bottom and the top of the cylinder is at the y and z axis, while the height of the cylinder is at the x axis. Okay, let me sketch for you. Okay, we have z, y, and x. Okay, so it's located here. This is x equal to 0, the bottom of the cylinder were located at the z and y axis. This is x equal to 10, okay, and this one, okay, is the y squared plus z squared equal to 25. Can you see it? Okay, the cylinder is located on the x-axis, the height of the cylinder. Now, the height of cylinder now is at the x-axis. Okay, inshallah. Okay. All right. Now, back to the question. V is a closed region bounded by the planes x0, x10, and y squared plus z squared. In the first octant, you have to consider this term also. First octant. So this is a full cylinder, right? Go to the first octant. So what happened is, okay, let me sketch it Okay, alright. So first octant, so what happened in this in first octant at the y and z axis. Okay, then this one I follow just this okay. So I have here first octant cylinder where okay the plane at the back is x equal to 0. The plane front is x equal to 10. Okay, x equal to 10. X equal to 10. This one is y squared plus z squared equal to 25. We have another plane actually, but don't worry because we just want to consider that we want to show that this is a first octant cylinder. Okay, so here, okay, now, so you understand that you are going to do the volume integral of first octant cylinder. So when you want to do you want to solve the cylinder, you have to consider the polar coordinate of cylinder. Okay, alright. Polar coordinate of cylinder, as you know, x is r cos theta, y equal to r sin theta, z equal to z, and now you want to do dv, so dv will be r dr d theta dr d theta dz. Just based on the formula given, this is original polar coordinate of cylinder. We know that the r is the radius, this is radius, r is radius, theta is angle, and the z is the height of the cylinder. But you realize or not, the height of our cylinder for this question is located at the x-axis. So what you have to do is you need to change the polar coordinate. Okay, you have to transform the polar coordinate to be the new one, where now you are going to do x will be equal to x. Okay, just change x and z. Y will be remain as r sin theta, and z now take the x polar coordinate, and the dv will be r dr d theta dx. Okay, so this is the polar coordinate, the new polar coordinate that you have to consider for this question, because the height of the cylinder is at the x-axis. Okay, alright, I think clear. Okay, now, so you have to consider this new polar coordinate for the function that we have. Okay, what's next? Okay, so function given is z minus x plus 4yz. So why don't we change this first? Z minus x plus 4yz to be in polar coordinate of cylinder. So z is r cos theta, x is x, plus 4y is r sin theta, z is r cos theta. You remember, right? We have understand before. We change the polar coordinate to be x equal to x, y will be r sin theta, and then z is and z we have changed to be r cos theta, because the cylinder is located, the height of the cylinder is contributed by the x. Okay, now, so simplify this, what we have is r cos theta minus x plus 4r squared sin theta d sin theta cos theta. Okay, now you can integrate it now. Okay, you're going to integrate applying polar coordinate, applying the triple integral cos theta minus x plus 4r squared sin theta cos theta, and the dv is r dr d theta dx. Okay, if you're not clear how it become this, pause this video first and back back to the look at this video from the beginning. All right, now r will be, I will expand the r. I will have r squared cos theta minus xr plus 4r cubed sin theta cos theta dr d theta dx. Okay, so what is the limit of the integration? R, it is 0 to 5. How I know? This based on this. This is radius. Radius is 5. Okay, theta, because this is first octant cylinder, so it is 0 to pi over 2. First octant, so 0 to pi over 2. And then x. X is obviously from here to 0 to n. Here, right? Okay, let us start the integration of r. Integrate the r. Okay, so I have here 0 to 10, 0 to pi over 2. Okay, so r cubed over 3 cos theta minus x r squared over 2 plus 4r power of 4 over 4 sin theta cos theta 0 to 5 d theta dx. Okay, so substitute 5 to the equation. I have maybe next slide. Next slide. Okay, so I will have. All right, now substitute the limit of 5 into the r. Okay, so I will have 1 to 5 over 3 cos theta minus 25 over 2x plus 6 to 5 over 6 to 5 only. Okay, 6 to 5 sin theta cos theta d theta dx. Okay, this one after I substitute the limit of 5 into the r. Okay, now proceed integrate respect to theta. Okay, so I will have 1 to 5 over 3 integrate cos is sin theta minus 25 over 2 x theta plus this one substitution limit and substitution method. So I assume I take sine as the u. Remember, you can use sine or cos because it has same power. So I use sine to differentiate sine is cos, so you can simplify cos. So now the sine will be power of 2 over 2. Okay, 0 to pi over 2. If you don't understand, you have to do manually. Let u equal to sine theta, differentiate u is cos theta, blah 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 blah. Okay, right. So now substitute the limit. You will get 0 to 10, 1 to 5 over 3 sine theta pi over 2 minus 25 over 2 x pi over 2 plus 6 to 5 over 2 sine power of 2 pi over 2 and substitute 0 will get 0 dx. Okay, so this is 1, this is also 1, so I have here 0 to 10, 1 to 5 over 3 minus 25 over 4 pi x plus 6 to 5 over 2 dx. Now integrate respect to x. Okay, 1 to 5 over 3x minus 25 over 4 pi x power of 2 over 2 plus 6 to 5 to x 0 to n. Okay, then you substitute the x. Okay, substitute n here, so you will get the final answer, which is 10625 over 3 minus 625 over 2 pi. So this is the final answer. Okay, so that's all for second example. Maybe we can meet in the next example. Thank you.